Okay, are we live? All right, that's our standard start for every live stream. So welcome to Convivial Code, a live stream for exploring the politics and pedagogies of vibe coding. So this is a part of a workshop that we've organized with the Center for Interdisciplinary Methodologies and the Center for Digital Inquiry at University of Warwick. Welcome to everybody here joining us in the room and also anyone who's joining us online. The session today is hybrid. We're also part of the StreamYard network, so we welcome anybody who's joining us across Europe as part of SAM. I'm just going to take a few minutes to introduce today's live stream and the workshop before handing it over to David Berry, who will give an opening talk. The phrase vibe coding was coined just over a year ago by an AI researcher, Andrei Karpathy, and he used it to describe a new way of writing software where you mainly interface with software through natural language and let an AI produce the code. So it draws on the vernacular or meme term vibes to suggest how you can iterate loosely with coding, and perhaps more atmospherically or aesthetically. So it's interesting, just I think as well, to focus on the way that meme culture and aesthetics is mobilized in the term. But for Karpathy, he suggested a different relationship to programming entirely. One that may hold different relationships to technical delegation, to cognition and reasoning, and to techniques. So the term was really our starting point for many questions related to all of those concepts that the workshop wants to open up. It's perhaps an older question that's continuous with modernity. What does it mean to work with a tool that you don't fully understand? But we're interested in what specific ways AI-assisted programming might change this scenario. And how does it affect computational culture more generally? Can it lead to new forms of technodiversity, or does it introduce or accelerate dependencies? Convivial is a term that we borrowed from Ivan Illich for this session. It's a term he coined in the 1970s in a very different moment. Technologically, he was writing about the emergence of a post-industrial situation, but we still thought it was relevant as a reference point for introducing some questions that perhaps are pertinent when it comes to vibe coding. His writing, of course, we should also read critically. There's a lot of gendered language throughout, but also he held a kind of suspicion of professional expertise of all kinds, including the kind that you would find at an institution like this. So there's also a kind of irony in running an academic workshop about conviviality in his terms. Yeah, we also need to think about what it means to draw from that work in relation to a completely different socio-technological conjuncture. Conviviality, nevertheless, for Illich was the opposite of industrial productivity. He described it as autonomous and creative intercourse amongst persons and the intercourse of persons with their environment. There's a kind of 60s resonance, I think, with an emphasis on the creative individual. But he also posited this scenario in opposition to what he said, what he described as a conditioned response of persons to the demands made upon them and others by a man-made environment. So the distinction is between tools that can expand what you do, think, and make, and those that circulate or nudge your activity into someone else's intentions. So the convivial for Illich, in this sense, it's not about being sort of warm and friendly. There was even an irony to his use of the term, but it was closer for him to a more disciplined and creative engagement that wouldn't distract from or undermine a genuine human connection, And there was a certain kind of demand placed on conviviality. Yeah, I'll just mention a couple of other points related to this concept. One is that he posited it in relation to two dynamics that he saw in relation to technological development, what he called watersheds. The first is where technology seems to deliver new efficiencies, new gains, maybe new capacities. But then a second watershed would occur as this technology began to fold in on itself, overshoot those gains and introduce new problems, and perhaps even work against the very purposes that it was introduced to serve. It's a reading that perhaps resonates with concepts like reflexive modernity and risk. But related to that is what he called radical monopoly, which was actually even distinct from a market form of dominance. So for him, a technological radical monopoly occurs when alternative ways of doing things become socially unacceptable or literally unthinkable through technological development. So that the car doesn't just make walking less efficient, but it redesigns a whole city so that walking starts to become impossible. And of course, there are clear links here, I think, in terms of how we're all critically thinking about AI. In his words, he said, the hypothesis was that machines can replace slaves. The evidence shows, used for this purpose, machines enslave men. So his remedy for this was that we need new tools to work with rather than tools that work for them. And we need technology that makes the most of the energy and imagination that each individual has. I should also mention that this workshop was funded by the Inclusive Education Fund at Warwick. And so we thank them for the support, but it also reflects a real commitment that we have throughout the whole event to think through how these changing conditions in relation to technology transforms participation, empowerment, and across existing intersectional dynamics. I should also mention we have participants today from across many different disciplines and career stages, including a number of international students. And I think that this should be an interesting day because we are all sort of positioned in slightly different ways in relation to this technological landscape. And it's a unique opportunity to collectively explore these technologies when normally we experience them in very individual and personal ways. Okay, having said that, I'll make some introductions to our three speakers. We have David providing a keynote talk and then two respondents. So David Berry is a professor of digital humanities at University of Sussex. He's the co-director of the Sussex Humanities Lab. His research addresses the theoretical and critical challenges of computational media with special attention to software algorithms and what he's recently been theorizing among others as a vector medium, which is a shift from symbolic to statistical computation. He's the author of several books, many of which people here will know, including Philosophy of Software and the forthcoming Artificial Intelligence and Critical Theory. He's also co-author of the forthcoming MIT book, Inventing Eliza, How the First Chatbot Shaped the Future of AI. And then we also have two respondents. The first is Janna Joceli Omena, who's a lecturer in digital methods in the Department of Digital Humanities, King's College London. She's a member of the Public Data Lab and the Alan Turing Institute's interest group on knowledge graphs. And her research investigates epistemological dimensions of AI, web technologies, and research software and method design, with a focus on developing accessible, reproducible methodologies. So we're very thankful to have her insights as well. And finally, Bernhard Rieder unfortunately couldn't join us today due to illness, but luckily, Michael Castell from CIM, Center for Interdisciplinary Methodologies, has stepped in as our second respondent. So he's an associate professor here at Warwick, a Turing Fellow, I believe. Used to be. And his research sits at the intersection of science and technology studies, economic sociology, and history of computing, with a special focus on cultural and institutional dimensions of machine learning and AI. He's the co-editor of The Cultural Life of Machine Learning, an incursion into critical AI studies. Okay.
Thank you.
I'm going to pass it over to you, David.
Thank you so
Take
much.
it away.
Thank you. Thank you. Should we wait to hear the talk before you applaud, to be honest? Thank you for the invitation, Michael, and to CDI and to Sim for the invitation to come and talk here. I'm going to be talking about vibes, and I just want to note that it's the first time I've been here in apparently the Media Lab, implying there's only one here in the university, or the one. And I quite like the vibes in the room. It's kind of part student occupation of the university building and kind of part anarchic kind of TV, guerrilla TV style room, which is kind of interesting. So today I'm going to be talking about vector coding. And I'm going to try and do two things, really. I'm going to introduce you to some of my newest work, where I'm thinking about a paradigm shift, essentially, in the way in which media is being created, distributed, and consumed. And I'm also going to try and connect that to vibe coding as a kind of case study that is useful for us to think about these kind of medial changes. Before I start, though, I do want to connect to what might be the digital project, for me at least, which is ELIZA. And this is convenient as it allows me to introduce my book at the same time. Essentially what I want to say is that programming is changing. Programming in the digital paradigm was a particular form of practice. In this practice, the programmer constructed, wrote, developed, edited, could read and see the code. And this was an important and hard-won, actually, practice. It wasn't obvious that this would be the way that you would control these kinds of gigantic electronic brains. It took time to develop the layering, the abstractions, the systems, the operating systems even, the time sharing. And ELIZA is quite useful because it stands right at the beginning of this process. Weizenbaum, I'm sure you know, allegedly wrote. There's some concern about whether he did or did not write it. It could well have been partially written by graduate students, as would have been common at the time. But certainly, when he was writing, he was there at the very beginning. In fact, he actually built one of the very first digital computers at Wayne State University. And this digital paradigm is interesting because essentially what's happening is it is a relationship of the human providing the meaning into the system. The system, the computer system, is essentially controlled, it is directed, it is limited in many ways. It is discrete, that's very important, of course, for the way in which the digital is formed, and actually it becomes symbolic. Again, ELIZA and Weizenbaum lie on the movement from numeric computing to symbolic computing. And ELIZA was hard to program because the programming languages at the time didn't handle symbolic programming very well. And this is very important, I think, because it's the beginning of the contestability of software in a way, because when you write software in this quasi-English pseudo kind of code language, which is later compiled and turned into machine language, as it were, you can question, you can challenge, you can read the code, right? And this is, of course, very important for the development of code, that others can read the code. Now, of course, we've lived over the past years, 60 years or so, since the beginnings of this kind of digital revolution, and companies have learned to make software proprietary. They've learned to use different kinds of digital rights management, DRM systems, to close down the possibility of actually reading the code. And there has been a pushback with open source and free software, which of course is a very important history in relation to the digital. And this obviously continues to the present day. But there are some important caveats that I'm going to come to as we go through the talk. Now, this description of the digital would not have surprised anyone 10 years ago. But I think now, as we enter what I think is a new paradigm of computation, these ideas about how one programs a computer, even one as archaic as the IBM 7094 in 1964, 5, 6, 7, 8, was recognizable. You could understand what was being done 60 years ago. But in this vector paradigm that I'm trying to think through and theorize, things are changing. And changing in really rather counterintuitive ways, counterintuitive to our essentially inherited notions of what computation is, how computation works, what programming is, what programming should do, how it should have a relationship with its programmer, and so on and so forth. So I'm theorizing the idea of a kind of shift from digital computation to vector computation, and essentially a shift in the medium itself. And that shift in the medium is absolutely important because the kinds of affordances of this medium specificity that I want to discuss really is beginning to play out in lots of interesting ways. Now you might say, why would I claim that there is a paradigm shift for computation? Why is this just not the digital, and that the digital can explain this? Well, the reality is, in a kind of true Kuhnian sense, is that when we are trying to understand LLMs and AIs and diffusion models and all the rest of it, we're actually struggling to use the categories of the digital to make sense of it. And certainly in terms of either harnessing or critiquing it, being wedded to those older digital concepts and ideas, I think are problematic. So the anomalies are kind of piling up. And I think if we were to shift our theoretical frame, if we are to shift, and I think we will have to shift our concepts and ideas, it gives us a new power. Indeed, if we are going to gesture towards conviviality, to take control of these tools, understand them, and use them. So first, I'm going to do a very basic and quick introduction to some of the ideas that I'm going to talk about. Many of you may already be aware of these ideas, but just in case, I'm going to be using the word vector probably quite a lot, so it's quite useful to know what that actually is. So firstly, it's not a very complicated thing. A vector is just a list. It's a list of numbers. And when you have a list of numbers like this, it's very amenable to calculation because you can do all the standard calculations on it. And what's fascinating and strange about this is the precision of the digital no longer becomes the important issue. It is the dimensionality of the model for encoding. And if the dimensionality of the model is more important, i.e. the size of the vectors in and of themselves, they become the site of encoding. When that happens, it changes the way you do the kinds of computations you do, and it changes the kinds of relations the encoded matter has with the environment in which it's working. So it is a very counterintuitive thing. Now, vectors exist in what is called vector space, or certainly what I am calling vector space, and I'll explain that a little bit in a second. But essentially, what you have is the number of vectors, which are essentially an array of numbers, gives you the dimensionality of the vector space. The higher the dimensionality of the vector space, the greater the capacity of the model to encode data. And this is really linked to the so-called scaling law that you'll hear all of the tech bros talking about all the time. They, at the moment, or some of them even believe it's a kind of infinite scaling law, believe that as you make the dimensionality bigger and bigger and bigger and bigger, the capacity of the models seems to follow this in a natural way. Now, whether that breaks down or not, we don't know, but certainly so far this appears to be playing out. This also explains partially why the computers they need get bigger and bigger and bigger, because the dimensionality requires more and more computational resources. It also explains why there is currently a shortage in RAM and compute, because of the complexities of running these vector spaces, the computation required for it. Now, we should note at this point that this is not a new technology per se, and actually Bernhard Rieder does a very good job in his Engines of Order, giving us the kind of history of vectors. And vectors were at one point in the kind of connectionist model a competitor to the stronger symbolic AI that seemed to be the future of artificial intelligence. As in many things in history, there was an inversion, and actually it turned out that connectionism suddenly became more capable with the growing capabilities of the machines. And we are currently living, I think, very much in a connectionist age, and the vectors and vector space are an important part of that. So let me try to give you a quick introduction to vector space. So that's not what it looks like, of course. That's a visualization. But it gives you a sense that it's this odd place, location. You'll notice spatiality is very important in the discussions I've got. I won't be talking about temporality much at all. That may be for a later talk and maybe something quite interesting to take up in the questions. But in terms of this talk, I'm going to be very much talking about the spatiality. And what it seems to be is this kind of vector space, this odd thing that you may have heard of, is able to suck in any kind of media, deformat it in a way, and dissolve it into this mathematical space. And from that dissolving of the media form comes its power because of the mathematization, or better perhaps the vectorization of the different forms of media. And then when you reverse the process, you have the possibility of synthetic media as an output. That is generated media that in some weird way brings together the fragments of this dissolved media form, whether it be text or image or what have you. And as all of us have found over the last 4 or 5 years, this really rather remarkable situation and competence of these machines. So let's dig into this a little bit. So, vector space. One useful way, and certainly the way in which I'm conceptualizing it, of thinking about vector space is it's a large rectangular space. It's a space within which numbers can sit. And vector space is very much useful to think of as a kind of like a room, like this room. And the majority of the space in vector space is always empty. That's one of the strange things about vector space. And when you train an AI model, what you're doing is filling the vector space with structure, because there is no structure in an empty vector space. I just want to point to, because I think it's super interesting, although I haven't got time to talk about it more, the strangeness, and this also points to the paradigm shift towards vectors, the strangeness of the number format that's used for the training of these models today. And it's down there as bfloat16. bfloat16. Now, bfloat16 is fantastic, firstly because it means brain float, which is a wonderful coinage. Secondly, because it's only 16-bit. 16-bit in our age of computation is very imprecise. It doesn't seem to make sense. Why would you have such a low precision number for such complicated computations? Well, it turns out the digital precision is not the key to the capacity of LLM models, or diffusion models for that matter, right? It's actually the dimensionality, the vector space. And this is why an attempt to use the digital to explain vector space becomes problematic. Because the vector space and the vector computation operates in such a different way. So for example, once you have trained your vector space in bfloat16 and you have a very capable model, you can do things that are counterintuitive to digital ways of thinking. Now, if you grew up in the digital, like indeed I did, you'll know the assumption that going from 8 bits to 16 bits improves the computation. 16 to 32 bits increases the capacities and abilities of the computation. Higher resolution, better audio. From 32 bits to 64 bits, also correspondingly making computation better. The strange thing about the vector world is that does not hold true anymore. Increasing the precision of the vector space does not make the models better, right? That's very interesting. The second thing is that when you have trained it, and this is very counterintuitive for anyone who has a digital mind, when you have trained it in bfloat16, which is a 16-bit number, you can halve the bits to 8 bits and keep the capacities of the model. I can't think of a digital way of working in that that's similar. You can also go and half it again to 4 bits. Now you have an LLM in 4 bits that has the same kinds of capacities of the 16-bit. Halving the bits, i.e. degrading the precision, allows the models to fit on your phone with the capacities of the trained model. Now you have to train at the higher rate, that's very important, or certainly that seems to be the requirement at the moment, but then you can half and shrink them down. Apparently some of the companies are working with a 2-bit number format. 2 bits to hold an AI, an LLM. It's so counterintuitive, I think, to thinking in terms of the digital. So that's just an aside, but I think it's just quite interesting, these kinds of anomalies, these kinds of strangenesses that we need to think through. So what goes into vector space? Well, what goes into vector space is what I call the manifold. Now, I call it the manifold because I think it's useful to distinguish between vector space and the manifold, the data, the trained data shape or structure that's within it. You'll see in the literature at the moment, many theorists are collapsing these 2 things into one. They often call it the latent space, which is a kind of convenient shorthand. But actually, I think keeping them separate not only makes it easier to understand what's going on, i.e. you have this empty box and you're filling the box with structure, but also the political economy of this new world is easier to understand. And I'll signpost the fact that it's the ownership of the manifold that seems to be key for the coming vector capitalism that we're entering. So when you're using this manifold in various ways, you're able to see different kind of structures and work through those structures. For example, you may have various kinds of submanifold that are structured around a particular subject area or a particular set of concepts or a particular theme. And that is essentially the training data places all of these ideas and concepts, all of these things together in various ways. It also has interesting implications in that if you do strange things like target an area outside the vector space, there is nothing. There's just nothing. And this causes all sorts of anomalies and problems for vector calculations. So you have to essentially negotiate the manifold. That becomes the key site. Each company owns their own manifolds. Right? That's very important. So Claude is the manifold of Anthropic. ChatGPT is the manifold of OpenAI. Right? Of course, there are different versions of their manifolds. It also implies their manifolds are incommensurable. Translating between them is actually quite difficult. That's where the money is, or seems to be, or that's where they think it is. And that's certainly the proprietary area of vector capitalism. They don't own the vector space, but they certainly own the manifold. Now, this is absolutely crucial to understand because as we enter this kind of vector computation, it has knock-on effects for discourse, for the public sphere, for the way in which we undertake our everyday activities. And of course, the key point of our workshop today is coding software, or vibe coding, as it's been christened. And why it's very important to understand this element of vector computation in relation to the kind of practices we're going to be exploring today is that there are certain kinds of what you might call affordances when you run things through the manifold, as you are all going to be doing. And some of them I'm going to try to gesture towards, but essentially what happens is the manifolds shape what you do through their distribution, the probabilistic distribution of data within the manifold. They expect to work in particular ways, one of which is a kind of regression to the mean, a kind of regression to smoothing, to synthesis, to non-contradiction, and so on and so forth. And I'm going to give you some early examples of where I have been exploring this. Additionally, when things are not in the manifold, the data that's passed through it, the prompts that pass through it, have a tendency to move towards whatever we call gravitational weight, the areas of the trained data, the densities of the manifold. Now, all of the analogies when we try to think of the manifold, and I should have said to you, all of these are visualizations, right? clearly I'm representing it in 3 dimensions. The manifolds can be anything between, I don't know, well, 3 dimensions and 32,000 dimensions, which is why it's so hard for us to understand them. When you translate them down to 3D so we can get a picture of them, it is a representation, it is a picture. We should always remember that. So when I use metaphors like gravitational weight, etc., it's really trying to think through the way in which we can understand the processes that take place within this kind of vector computation. So this, and I'm sure you've seen this when you run any text through an LLM, this tendency to smooth it, to have this kind of blandification. I was talking to Ian yesterday about, I've been experimenting with, I think it's called Sonu, the new LLM, audio LLM. A very interesting thing to do if you have a chance to play with it is to actually recurse your music or sounds through the model. And it's really quite interesting how it smooths, it just smooths it until eventually you have this kind of ball of blandness, which is really, really fascinating. And all of the models have this tendency because of the way in which they work. Now this actually, ironically, is really good for programming. Because for programming, actually, you want those standardized methods for approaching various kinds of programming tasks. And I think that points to perhaps the power it has in relation to computer programming and these kinds of, any kind of like bland processing, like bureaucratic procedures, performers, Excel spreadsheets. It's very good at doing those kinds of things because those are such standardized activities. Now, I gave a talk in February in Greece, and after the talk there was a fantastic discussion about the fact that the Greek language is underrepresented in the LLMs. And one of the things they were demonstrating, because they were all authors and poets in the audience, is that it wasn't that the Greek language causes an anomaly or causes an error or a rejection. It's that the Greek language, because of the density of the English language within these training models, becomes anglicized in really bizarre ways. And they would read out Greek poems and Greek texts that they'd ran through the LLM. So they would all burst out laughing because of the ridiculousness of the corruption to their own language. And so what's very interesting, and I think a very fruitful future area for research, is actually looking at these kind of silenced spaces, the absences in the space, because the absences aren't reported. The models have a tendency to smooth out those absences. They won't really acknowledge them, and I think that's a very interesting issue. You can think of this as I say there, that somehow the prompt or the query that you're putting in is bent towards an attractor. And one of my favourite attractors, actually, which I very strongly advise you to kind of look at, is the bliss attractor. The attractor that's been built into the LLMs to increase positivity and supportiveness and helpfulness within the LLMs. And that has produced lots of complaints of sycophancy. And one of the reasons is the way in which the training data has been structured. So this smoothing is, I think, a very important part of the question. And one of the things I'm exploring and asking questions about is whether these machines are essentially anti-dialectical machines because they can't capture the negative. Now that's very fascinating. Now I just want to be clear, this is not that the model is misfiring. This is the design of the model. The way in which the system works means it can't deal with contradiction. The way in which the training data is placed within the manifold is essentially one of a distribution based on lexical density, for example. And this has a tendency to group like with like. To give you a very basic example of this, fair and not fair would be placed very close together in the manifold, right? And this has all sorts of very interesting implications, I think, for the way in which these systems work. So when you, and I'm sure you've tried this, put two disparate contradictory things together into a prompt, the response that comes back is this weird conglomeration or aggregation that attempts at synthesis. These are synthesis machines in a very conservative vein. And I think this is why people like Richard Dawkins going through a kind of strange relationship with Claudia, as he calls his LLM, because he puts things in. It not only tells him he's a genius, but also anything he puts in, it tries to synthesize together and say, wow, you've thought of an amazing new theory about X and Y. And there are lots of examples of people, maybe some of you have tried it, mixing up, let's say, quantum theory and structuralism, or quantum theory and your child's development. And the system will try to put them together and go, oh my God, you've created a new theory of child development based on quantum theory. You should really publish this article, right? It's a kind of an odd part of this. And of course, this is important because this plays out at large in public discourse, which is being run through these systems. So I don't want to go into the depth of this. I think it's quite interesting. I'm just going to put the words really up for you to go and have a look at yourself. But this is essentially a question of cosine similarity. Proximity is very important. That's a spatial concept, of course. It's a space. Where things are in the space is important to how the system works. So, for example, the statement, this law is just and this law is not just, are located close together. They're not negated. That's very important. Negation doesn't seem to be a quality of these systems. So I've built a variety of tools that explore this, and I'm going to just talk to them briefly at the end. But essentially, one of the ways of looking at this is calculating this geometric distance. And you can see here with the mini LM model from Hugging Face that essentially the law is just and the law is not just is found to be, essentially very similar in this model, right? Which is very interesting. And you might say, oh, well, it's just an LLM. Well, mini LM, even though it only has 384 dimensions, actually is used for a lot of RAG processing. So it's being used already for document retrieval and confuses these things. That's interesting, right? We need more research on this. We need to find out what this means in practice. But I think it's an interesting affordance, if you like, of the software. And here is the latest Gemini model, which is 3,072 dimensions. And it's slightly better, you might say, but it's still, these things are still very closely located together in the manifold. So I think these kinds of questions are kind of interesting to ask. Oh, by the way, at the bottom, oh, you can't see it. At the bottom is the web address that you can't see, if you want to have a go with it. Hopefully it'll be further up in a later slide. So there you go, they're located together, so you can see how these things get collapsed. Now, I think this is very, very interesting because this smoothing reminds me very much of the Frankfurt School and the notion of the rise of instrumental reason and the regression of enlightenment into myth. And indeed, the notion, and actually kind of ironically, the one-dimensionality pointed to by Marcuse, right? We're seeing dimensionality as a real concrete technical process. And, in terms of the myth, I do want to just note the tendency of the mystification of AIs, right? Because we find them so hard to understand, we instead mystify them. They are not mystical. The one thing that I want to make clear here is that we can unpick them and start to critique them. So discourse goes through these models. The public realm is increasingly full of it. Anyone on LinkedIn will know the horrendous amount of AI slop, not only just in people's posts, but also in the comments, where essentially you get these very strange situations of this hyper positivity and almost sycophancy that's being reflected by people using these AIs to essentially communicate with each other, right? And so you can see this it's not just a technical question, it's a social question and it's a political question, I think, too. Because I was reading the other day that some people have been doing, oh yes, that was the study. I don't know if you've seen it, but there is a strange emergence in the last couple of years in MPs' speeches to the Houses of Parliament, so you know it, yeah, of procedures from Congress. So they're quoting procedures from Congress in Parliament, on the floor of Parliament. It's getting recorded in Hampstead. And the conclusion is AIs are writing their speeches. And so pulling in, American notions of political procedure. So these kinds of things are leaking into all parts of everyday life. And of course, friction is very important. I think the agonistic as an important part of political life. Well, when we have systems that naturally smooth out any kind of friction in society, that I think will have really bad impact on our political ability to negotiate important issues, if we're all using AI essentially to mediate our relationships. And I would also like to point to, and this is very important at Warwick with your attachment to controversy and controversy analysis. Controversy itself becomes a faux controversy if it's mediated through these systems. And also we might ask questions about the indexicality of the kinds of methodologies in digital methods and controversy analysis when so much of the textual and discursive realm is AI generated. That's a very interesting kind of methodological and theoretical question, I think, more generally. So you'll be pleased to know I'm going to get to coding, and essentially the question really is what is happening to this very specific sphere of practice. Coding is in some, and very strangely, at the forefront of this kind of process. Because of its systematization, it really lends itself to the kind of automatization that these systems produce. And as I say, that's very much related to the very structured way in which code is structured, and also incredible training data. You all no doubt know about the Stack Overflow situation, where that was essentially mined for programming techniques and bugs and technique. Now, coding is also expensive, so there's a labor issue, right? Coding is slow, coding is difficult, it's prone to error, and requires considerable expertise and time to do. If you read the early stories of the computer revolution, the early stories of Apple, people pulling all-nighters, working for ridiculous hours with just pizza and I forget what the drink was now, but the Kool-Aid that they used to drink. They essentially, had to spend so much time on this software, but it was expensive. Even now, programmers at Google, for example, start on over £200,000 a year as a starting salary. So companies, when they see an opportunity to reduce labour costs, they really do jump on it. And the technology companies are very excited. There's been a whole swath of cuts to labour across the technology industry. Meta, Google, I heard Block. I think Block laid off 40% of its employees last year because of AI, right? Now, of course, this may just be froth. It's very hard to know. But they're claiming that AI produces the possibility of a highly effective and very small team responsible for coding. In fact, Sam Altman has said his dream is the one-person billion-dollar company where that one person, because of AI, essentially has a swarm of agents doing the technical work, the financial work, and so on and so forth. That's kind of a strange vision of no worker workforce. And again, has lots of very interesting questions that we should think in terms of political economy more generally. So coding is very interesting because we see this subsumption of labour very much at hand. I like it as well, not that I like it, but I like it methodologically because there is a lot of interesting discussions going on discursively online about what this means and people discussing how it's impacting them in the everyday. So there's some wonderful PhDs, I think, to be written about this subject. But also the way in which it's not just proletarianizing the programmers themselves, but it's also transforming the processes of work itself. Now, the practices that are being developed here in terms of coding, the AI companies see as transferable. The next site of attack, as it were, is the legal profession. Similarly systematic, similarly procedural, they see a lot of value there. Meta, interestingly, has decided that marketing and public relations is another site of a very standardized set of processes that, again, taking this model of coding, you can essentially make people redundant, workers redundant. So what does that mean in terms of coding? Well, to run the same kind of searches in, for example, Google here, one of their frontier models, what's fascinating for me is when you put code into these models, you get similar strange results. So for example here, this code return result and return minus result is essentially indistinguishable for the LLM, right? So very fascinating that the same problematic with negativity is applying to the coding realm as too. I've done it with a few different ones. These could be bugs, of course, in your code. If X is none, if X is not none, right? That would be an easy bug to make a mistake on. Or in this one, for 1 in a range n, and then in the other one for 1 in a range n plus 1. These are easy bugs to put in code. These systems are very strange to think through, counterintuitive. We need a lot more ways of thinking through them. So I've got this kind of very kind of what would I say? A kind of very general idea of what is happening in terms of programming. Just for this kind of workshop, really, I've tried to sort of break it into 3 ideal types. So we might think of we have classical coding, vector-mediated coding, and vector coding. I'm avoiding vibe coding because I think we need to unpack that a little bit. But essentially, classical coding, of course, is the old world, the digital world, the world of source code, the world of the kind of long all-nighters and all this kind of stuff. Number 2, the vector-mediated coding. That's very much, I think, what we're going to be doing today, or most of us are going to be doing today, which is a kind of what was called co-piloting 3 years ago. I know that's also a branded product, but it was the idea that somehow the coder was your friend, you would be co-coding with them. And in this practice, what you've got is it's augmenting your programming ability, right? If you've done any vibe coding, you'll know this from the notion of diffs, that the program's constantly showing you diffs, differences between and after, and essentially helping you build the software. Now, why is it showing you the code in diffs? Because you're the programmer, right? You're the judgment maker, as it were, right? And you know, it has and does continue to massively increase the productivity of programmers because of autocomplete and all these kinds of practices it makes possible. But in the vector coding mode, which is really context engineering, what we see is actually a gentle code production, where the code is written in total without coming back to you for help. It just goes through the whole process and writes the whole software, and then goes, there you go. Is that okay? In that model, no diffs are shown to you, no files. You don't know the structure of the file system. You don't know the structure of the code. You don't even necessarily know the programming language. And that, I think, is the moment of essentially the end point, right? The could we call it the abolition of the programmer as such? So these are all, you know, continue to overlap, right? We still have different moments going forward, but you know, obviously the third one is the one that the tech companies are massively betting on, and of course, remember the translation to other industries. So the conditions of code are now being set by the manifold, and so what becomes very important as a political economy is that who owns the manifold controls the programming. And of course, these models, and particularly for these gentle program models, it's the frontier models, and of course there aren't many of those, and of course those are owned by giant corporations. They are essentially taking the labor of programmers and able to control the kinds of programming that takes place elsewhere, and the kinds of programmer, and the programmer's subjectivity per se, we might say. So, who owns the manifold, I think, is going to be a key political economic question, and one perhaps also important for wider policy and regulatory questions. So convivial code will have to, I think, really deal with these questions of the ownership and control of the geometry. Open weights is part of the answer, perhaps. Notice that it's open weights. There are very few open source models. We have to be very careful about this confusion of language. And even with open weights models or open source models, the training is so expensive, so takes so much time, so much energy, that the reality is only well-sourced companies are able to do this. In a sense, you might say vector computation is a product of a particular kind of financialized capitalism. If we just look at the circular economy of this vector economy, you see that in and of itself, right? We are in the middle of a strange vector AI bubble, we might say. We also note that the programming window, the prompt window, sorry, is the new programming interface. I think that's a very interesting question. I'm not going to be speaking to that particularly today, but that becomes the key site of the relationship between the, shall we call them, the manager and the programming model, right? Very, very important. Source code, as it were, is downstream. So vibe coding is kind of interesting in lots of different ways, but we obviously need to unpack and contest it. So, the question is, what is vibe coding? Well, Karpathy has already been quoted by Michael. It's this idea of essentially putting aside the engineeringness, the software development, the long and hard processes of professionalizing the programming industry that took place since Weizenbaum's very much craft-driven processes to the much more formalized notions of programming today. In a way, this is just give in to your craziest creative thoughts and let the computer take control of the process and see what happens. And just play with the software. So it has this odd celebratory dimension to it in relation to these technologies. And you know, you're very familiar, I'm sure, with the kind of language that comes out of Silicon Valley. This is very much in those veins. And as a result, like mushrooms, the vibe coding space has exploded. Some examples here you may have looked at, but if you haven't, I would really recommend. Cursor, which was one of the first, perhaps most important movers, although now it has lost its edge in many ways. Cursor, ironically, was just a fork of VS Code with a thin wrapper over the top. Now it's a $60 billion company, which, you know, kind of strange. Claude Code, very important, Claude Code. Claude Code was vibe coded, right? The chief engineer of Claude Code, there's a wonderful interview on YouTube where he describes the process of vibe coding the very tool to do vibe coding and how there is a kind of circular loop on Claude Code, that the massive jumps in the quality of Claude Code are due to the vibe coding of it. Now, we might have thought he was exaggerating. A few weeks back, accidentally, Claude leaked the entire source code for Claude Code's harness, which was rather amusing. And when people actually look through the code, it turns out, indeed, yes, it was vibe coded. It uses all the kinds of scripts like TailScript, etc., that you use in a kind of vibe coding environment. Not only that, it has lots of redundancy, lots of the kind of code AI slop, as it were, that these kinds of vibe coding systems produce. A bigger question is, does that matter? You know, Claude Code is a remarkable product if you haven't used it. I do really, really strongly recommend you have a go with it. And I know one of the groups today will be gesturing towards it. Codex is obviously OpenAI's late response to Claude Code. They haven't told us whether they vibe coded it, but one thinks they probably did. Replit Agent, ADA, Lovable, Bolt, and VO as well are different ones that I recommend you looking at and playing with if you can. Like I said, that Cursor is now worth $60 billion due to its funding rounds. And actually, Elon Musk has just put in a $10 billion option to buy it this year, if he wants to. Elon Musk, of course, I'm sure I don't need to tell you who he is, but this guy owns a lot of things, the world's richest man, essentially, and he's about to IPO SpaceX. With the IPO SpaceX, I was reading yesterday that it would mean that he would be worth 3% of American GDP on his own, which would make him the richest American in history, richer than Rockefeller. So this is why vector capitalism is really important for us to think about. As I say, there are them. So I've talked about this already, but this kind of labour of coding is replaced, and the process of working through materials is changed as well. It's such a strange way of working It really is. It's so counterintuitive. It's so not like programming when you start getting a hang of the vibe coding. And I've been vibe coding now for 5 months. So I feel like I've really got a good sense, not only of the different levels of vibe coding, but also the weird autonomy of it when you let go of the leashes. At first I was sort of super anal about it. I would want to see the code and check what was being done. But very quickly, and partially as a result of the lines of code that are generated, I mean, once lines of code gets over 1,000, 10,000, 20,000, 100,000, it's impossible for you to check all of the changes. So you just let go, right? And that's very interesting in and of itself, I think. So this last process, this agentic coding, is our current moment where we are. The sort of per turn coding is being closed. You don't do that kind of, please do this, it does it. Please do this, it does it. You just lay out a specification and go, just do that whole thing for me, right? Very, very strange. And as I said previously, some of the new tools have this agent mode built in. Claude Code, I think, has a remarkable agent mode for doing this kind of process. If you've never experimented with it, just tell Claude to go into planning mode before it does something. It is really mind-blowing to watch how the agents work to really design the whole system. And remember, they're drawing on that trained knowledge from the manifold, from the millions of examples of specification documents, planning documents, and coding projects that it has within it. Very, very fascinating. This word harnesses is very important. I don't know if you've come across this, but harnesses are key to understanding this new world because the harnesses essentially cage the LLM and point it in the direction in which you want to work. So Claude Code is such a remarkable harness. So you could have thought of maybe, I don't know, of Claude Code as a kind of moat for AI. So them leaking the entire source code was a bit of a major problem, as they are supposed to IPO this year. Interestingly, we'll see how that plays out in lots of different ways. So yes, this proletarianization, we could say, is happening as the developer becomes the vibe coder, becomes the manager, becomes more and more abstracted from the product and alienated from the work. So this question then, to come back to Illich's convivial codes, we really have to have a grasp of this technology. We have to have an understanding of it. We have to understand the medium specificity, I think, of what I am calling this vector medium, the vector space, the manifold. And it's really important because I think it's doubly opaque, which again feeds back into the kinds of ways in which we think about these things. Not only is it unreadable in some sense and very calculable, it's probabilistic, it's hyperdimensional, it's vast, it's complex. We don't really have the tools to dig into it. It's very strange. And in terms of a media theoretic approach, the digital things, the digital concepts, the digital frames just don't seem to help us. But I also want to highlight the second aspect, that political economy. It's owned and controlled by corporations. That's very important, right? We need to unpick this new political economy around vector capitalism to get a better sense of it. Here's some of the questions we might think whilst we're doing our vibe coding. But essentially, the labour that's going on here, what's being done and who is doing it? And what labour, what dead labour, if you like, has been subsumed within the models? And what does that mean, right? What does that mean for even current programmers as they work and develop? Their labour gets sucked into the training for the future models, essentially proletarianising themselves in the activities of doing work in and of itself. One wonders when companies are saying it's mandatory to use AI in your work from now on, that what we're seeing there really is management deliberately proletarianising their own staff. In the university, we're given these licenses for Copilot fundamentally because the universities are very keen to save labour costs. They're very excited by the possibility of getting rid of staff, if that's possible. But also link it to the questions of the wider political sphere, I think, actually. This smoothing, this tendency towards synthesization rather than dialectical thinking. Okay, so I've already talked about that. I won't talk about this particularly. I just want to point to this pre-structuring of what comes out, again, for vibe coding, the kinds of code that's produced and the way it articulates the code. Keep an eye on it. It's kind of interesting. The decisions that are made which may or may not be what you intended, right? The questions over how we use the software, how much we have to babysit it, what it's requiring from us in that relationship of working through vibe coding are absolutely key. And I would say that if you notice you start getting a headache or you start feeling very tired, what's happening is you're babysitting the AIs in a very heavy way. And so what's going on there? What generation of model are you using? Because as the models have become more capable, they can take on more work. And Michael's nicely distributed, I think, different styles, different models in terms of the kinds of work we're doing today. This, I think, gestures not just back to Illich, but also to Agra. You know, a critical technical practice for this vector age is really important. And I see this as part of developing that set of practices, I think, that's not anti-AI. I don't think we should take just a binary pro or anti-AI response necessarily, but actually, you know, how we can develop critical technical approach to it. Let's try to understand this new medium and the affordances it makes possible. If you're interested in looking at some of the tools I vibe coded, there is the web address down there, vectorlabtools.github.io. The three top ones are the most developed and probably the most easy to get a handle on. It gives you a sense of the kinds of power. I'm not just talking about a noughts and crosses program, like a very simple little program here. The kinds of projects you can produce with these technologies are remarkable, really quite remarkable. So here is the Vector Lab with its summary text, whatever. Please do go and have a look at that. And it's those three at the top there that I would particularly recommend the first two, the Manifold Atlas and the LLM Bench, which allow you, and remember this is all vibe coded, right? I've just directed the kinds of theoretical questions I want to ask and developed particular modes of investigation, probes actually in a McLuhanite sense into the software. Manifold Atlas is interesting because you look inside the LLM. LLM Bench is interesting because it's comparative on the outputs. So two different tools, two different ways of thinking about it. The one on the right there, Diffusion Atlas, is about diffusion models. That's a newer piece of work. It kind of works sometimes. It's a bit more alpha, but if you want to play with it, please do. This is the kind of results that the Manifold Atlas gives you. You can feed it sentences, concepts, what have you, and it allows you to kind of map them within the manifold that you're particularly looking at. I don't know which manifold this one was, probably either Gemma 4 or Gemini. I can't remember which one it was. But you can see here, for example, I put in lots of text from accelerationism and from feminism, and then it maps it into its manifold. And it's kind of interesting to see that these two take different spaces in the manifold. They're literally distributed in different ways. Now, if I were to overlay, I haven't got enough time to show you anymore, but if I were to overlay other things, it's kind of interesting. Neoliberalism, it clusters around accelerationism. Critical theories of technology would cluster somewhere else. And it's kind of interesting to see how they're spaced within the manifold. Now, again, I'm just going to reiterate, these are representations. I'm casting multiple dimensions, in Gemini's case, 3024 or whatever it was dimensions, down to 3 dimensions. But I think it's interesting, right, to be able to visualize at least these complex objects. So you can see that I think new tools are part of the answer to answering the kind of theoretical questions we want to explore. Huge questions remain. I've already pointed to the public sphere. The question of the public sphere I think is still important. Political life more generally, questions of labour, questions of sociality, all of these kind of questions are changed dramatically by the advent of vector computation. One thing I have been wondering about is that if social media was the age of outrage, because outrage drove engagement on the platform, does the age of AI signal, should I say conviviality? But certainly helpful positivity and well-being, because the bliss attractor increases engagement, makes it attractive and addictive because it's so friendly. That's very different to the social media age. So that's kind of interesting in and of itself. And one thinks about whether we, kind of like a repeat of the filter bubble, we all have our AI bubbles, our little AI friends who are so complementary to us. So these are the bigger questions. The geometry, I just want to say, is already privatized. That's strange, actually. So in a way that the digital was not privatized at the beginning of the digital age, it's very different with computation under vector conditions. And that, I think, means maybe we need to move a little bit faster to get a grip on this new vector capitalism that seems to be emerging. And, you know, what would it mean to seize back control of the kind of means of vector production, as it were? It can't just be open weights, I don't think. What concrete political responses do we have that? And as a gesture, as I know to Michael's work, is that a tactical question of manoeuvre, or are we going to think in different political ways about changing this dynamic? Thank you so much. Do you want me to stay here, Michael?
Yeah. Do you want to take a seat? We might just move your
I'll take
laptop. And also invite. I realized I didn't introduce myself properly at the start of this stream, but my name's Michael Rieder. I'm the co-director of the Center for Digital Inquiry, and I'm joined as well by Carolina Bandicelli. Do you want to come up?
Yeah,
Bandinelli.
Bandinelli. But Bandicelli is nice, so I'll take it.
Who's also a co-director.
Yeah.
And I'll also invite our two respondents, Janna and Michael, to join us.
Forgot my block notes. I took notes.
Yeah, I have to say...
since 2015 that I took notes, so thank you, David. You gave me this opportunity to take notes. Please.
Well, I was thinking, like, we normally run CDI TV in a much more of a conversational style, but it is nice to shift gears, especially on this topic, because we have been discussing AI quite a lot, and it's nice to get this kind of perspective that's very detailed, I think technically and also critically engaged. So we have a bit of a structured discussion, but we're hoping that it will open up. We invite people online to make comments or ask questions, and also, of course, here. But yeah, should we?
Yeah, this is structured because Michael led on it. Yeah. So this is why, in case there's someone that usually follows CDI TV, if you notice something more structured, it's Michael merit, not mine. But following up on this, I took my notes. Because I felt like, oh, what do I understand about critical code studies? I get the critical, maybe a little bit the studies, but definitely I don't get the code. But it was less cryptic than I expected, so I even followed. And at some point, there were all, those images and the gravitational weight and things, and I got a little bit concerned, like, where are we going here? But then Anna Arendt, okay. We're back to the deers. But the only thing that I was thinking, which maybe much less articulated than what our respondents will say in a bit, because you're more like expert in the field. But what I was thinking is that I hear a lot in media studies, of cultural studies of technology, this shift from something that has to do maybe with, communications of meanings, maybe, or even the codification or a clear codification, the formulation of a clear code, to moods, vibes. So Ludmila Lupinacci universally talks about platform moods and vibes. Minna Ruckstein talks about algorithmic folklore, which is not how the algorithm works, but the kind of stories that we as users build around the algorithm. And then there's Alberto Costa from the University of Leicester talking about the sensorial shift. So from meaning, if we think about Do you remember the good old days of the digital public sphere, to go back to Frankfurt School and Habermas? Like, okay, then we can debate. There can be this friction that you mentioned before, David. And now if you think about, for instance, TikTok, it is much more about dancing or cleaning carpets. I'm brutalizing it. Yes, I am. But this is kind of the shift. But even if you think about the haptic media or the sound media, there's this engagement of the senses and of the feelings. And I think what you were saying about the friendliness of vector capitalism interfaces is quite important here. And in my research, I've been thinking I've been thinking a bit, not a lot, but about these affective economies of the platforms and of the media we are immersed in. And it seems to me that this, I don't know, could we think of a cultural shift from looking at these tools for what we can do with, or this kind of potential, which the use value, so to speak, which obviously is still there, right? But I think, but this is such a new thought, I thought about it 10 minutes ago, so I don't know if it has legs, but I'll say it anyways to break the ice, so then you can say whatever you're thinking because I said that. Whether there's a shift to how these media make us feel. So the relationship, the affective, the libidinal relationship that we have with this media, that it seems to me, I looked at it a little more in detail in my study on dating apps, which seems to me the core business, actually. And these sort of, I don't know, Michael, you with your interface studies you can say a little more about that, but maybe there's also this shift in an interface that tends to hide even more and more and more what is going on in the, I'll call it black box, because for me it is a black box, but that kind of hide the means of the competence to build this relationship or this performance of an affective atmosphere. So these are my 2 cents. And then let's hear from Janna. Janna, you have been working with digital methods a lot. This is the first time that I meet Janna, but I heard a lot about her, and I heard that she's one of the greatest when it comes to methods, like really thorough. So your fame, good fame precedes you. What do you think of this talk, of this vector capitalism, and maybe, I don't know, but I suppose we need new methods for this vector capitalism?
Well,
or maybe not. Maybe we do with the same methods. We don't need to invent new methods all the time.
No, thank you, Carolina. I have a few thoughts, but I just wanted to contextualize my structured response, which is more associated with David's AI vibe coding and critical studies blog. So if I may,
of course,
can I go for it?
Of course.
I'm partly to blame for
it's a free space.
Giving everyone to, but I'm sure that as well you have new thoughts and ideas that you just add to it.
I guess there are some thoughts here that of course connect with your inspiring keynote. Thank you so much. Back to this specific publication, the blog. I find David's discussion between cognitive delegation, productive augmentation, and cognitive overhead very helpful because it gives names to dynamics that many of us experience when working with AI. So in my own teaching and research, I recognize these dynamics, though I am more interested in how we learn to move across these categories and account for their frictions as part of methodological practices. Let me start with a disclaimer. I am responding from my slightly different standpoint than David, Michael, and Bernhard, if he was here. I am a digital methodologist with light coding skills and my relationship to code often occurs through methods, tools, and data work rather than hardcore, heavy coding practice. So I'm bringing a digital methods perspective. These methods, by nature, they are interdisciplinary and technical. So my response is organized in 3 points. The first is that vibe coding makes visible an old digital methods challenge. The second, how do we balance and account for engagements with AI? The third, engaging with AI mechanics of reassembly. So my first point is that vibe coding makes visible an old and still very present issue in digital methods, the easy path. So vibe coding allows code practitioners to experience a mode of working in which one can almost forget that code exists. I recognize this experience from digital methods training and teaching, especially when researching students who have never worked with web data or research software encounter tools such as Bernhard YouTube data tools. So I see their eyes widen and as if something magical is happening on the screen. At the moment, learning differences between scraping, crawling, API calls, data formats, or relational nature, rate limits, platform restrictions, or cultures of use, and two specific operations can seem irrelevant. So if I can access, visualize, and analyze my data so easily, why should I care about the technical conditions and ingredients that constitute a methodological ensemble? So I'm speaking the language of digital methods. But of course, this magic means very little if researchers do not understand what they're doing. This is why, for me, digital methods and vibe coding meet. In both cases, what matters is not simply keeping the human in the loop or vibing, but cultivating this kind of technicity thinking praxis needed to work with technical systems without being tricked by their easy path. So digital methods cannot be reduced to tool use, just as vibe coding cannot be reduced to prompting code into existence. In both, the practitioner needs to understand enough of the technical, social, epistemic conditions of the process to recognize when something is broken, partial, misleading, or methodologically inappropriate. This is also how I read David's discussion of taking over attitude. The issue is not only that LLM-generated solutions can fail, but that the practitioner needs to know when they are failing, what kind of failure is occurring, and how to intervene. So for me, vibe coding reactivates a familiar digital methods question. How do we work with machines that produce outputs before we minimally understand the conditions and practices under which those outputs are produced? One possible answer is that we should not treat broken, failed, or misunderstood AI outputs as exceptional surprises. Of course, AI fails, research software fails too. Scrapers and AI constrain us, data sets are partial, and the visible layers of the web can produce a homogenizing logic that can trick us when we analyze data. So the challenge with vibe coding is that the easy can make us forget what we don't understand. The methodological question should be less about how to remove these frictions completely and more about how to navigate them with discernment, recognizing when they matter, documenting how they shape the process, redirecting the work when needed, and accounting for their epistemic effects. My second point is that I am less interested in identifying which AI mode we occupy, delegate, augment, or overload, than in how we move between, balance, and account for different ways of engaging with AI. So I find David's distinction careful and useful, but I would read this valuable guidance less as a set of fixed modes one occupies and more as dynamics that appear within learning, researching with AI, precisely because they can overlap. So the key for me is discernment, knowing when to follow an LLM output, when not to follow it, and when to redirect coding or methodological practices. So this connects to something that I proposed last year in October in this recap with AI activity for all master students in our PGT dissertations module. I invited students to think AI as a thinking catalyst, a way to challenge and expand our thinking, a learning collaborator, a partner in planning and structuring, and a precision companion as a support for instrumental tasks. So their orientation, rather than fixed states, their strong dialogue with David's theorizing work with AI, while also translate this concern into more practical and pedagogical question, how students can navigate AI engagement with discernment while remaining the authors of their work. I'm moving for my final point. So my third point is where I want to complicate the discussion a little. I don't know, let's see. If we only focus on cognitive delegation, productive augmentation, or overhead, we may miss another form of engagement. The AI capability to reason around what we do not yet know by reassembling traces of our own or others' intellectual trajectories. And these traces, I'm meaning web traces. What I'm calling AI mechanics of reassembly means those moments when AI appear to recover, reconstruct, reassemble concepts, patterns, individual or collective intellectual trajectories from web traces. They are already there, but which we may have stopped noticing or not envisioning in that specific way. So one example comes from my own engagement with agentic AI as a researcher collaborator. So while I was debating a project title, very basic, Google AI mode bypassed my immediate question, which was essentially an A-B choice, and performed something closer to a longitudinal reading of my own published work. It replied that I should go for option A, and identified technical imagination, not just as a possible inclusion in the title, but defined it as my intellectual signature, a methodological concept that I had developed in my PhD dissertation. I had also been using intuitively, but had stopped noticing or thinking about more intentionally. Of course, my reply was, wow, what? Why? Show me the evidence. And this is where I would distinguish this form of engagement from a more instrumental understanding of vibe coding. So here, the moment of conceptual reactivation was sharp, not delivered as overwhelming production, and for me, unexpected. So it created a different kind of work for me. The moment when AI response interrupts the immediate task, A or B, and provokes a new relation to one's own research thinking. The point is not that AI simply does the work for me, or that I sit and wait for an output. So this kind of encounter matters, methodologically speaking. On one hand, it shows AI acting as a reflective mirror that, without being explicitly instructed to do so, can reassemble web traces and provoke changes in our own research engagement. On the other hand, it points to a posture that is different from taking over. It is closer to surrendering to the process. And I do not mean surrendering judgment or letting discernment go. I mean a temporary suspension of impulse that we always have to immediately take over, correct, measure, or instrumentalize the AI response. So for a moment, one allows oneself to receive what the machine has reassembled and to be struck by it, because it may return something that unsettles the task and activates thinking differently. So here, the methodological skills lie in these movements, taking over, surrendering to, or being overwhelmed by the process of engaging with AI. So if vibe coding is often framed around this easy creating through conversation, this points to something that I would call vibe researching, engaging AI not only to produce and materialize knowledge or artifacts, but also to expand thinking. So to wrap up, I would say that vibe coding and perhaps vibe researching requires moving between different postures, taking over, navigating with discernment, and temporarily surrendering to the process when the AI reassembles something unexpected. And this is where digital methods, AI critical studies, and perhaps critical code studies meet, not in choosing one mode of engagement, but in learning how to account for what happens when we think code research and make methods with AI. And from a digital methods perspective, the methodological skills may lie in this movement itself, like knowing when to intervene, stay with, or surrender to the process of engaging with AI.
Thank you very much.
That's my intervention.
Thank you, Janna.
Thank you.
Thank you for this very structured and precise intervention that kind of feedbacks on me and makes me try to behave as a proper chair. And so, as a proper chair, without messing around for now, please, Michael, would you share with us your response?
Yeah, sure. I largely agree with what David is saying about how sort of living through this Kuhnian revolution from the digital to the vectorial. But it's primarily true at the level of the architecture, at the level of this blob of weight parameters that some of us here have downloaded. And that has implications. It does have implications for anyone who cared about symbolic programming, code, traditional computing, and also for the humanities in general who have put so much energy into this word digital, right, which is now really problematized if you're focused on AI. And all the philosophical controversy about what does it mean for the things to be continuous and vectorial, that all existed back in the late 1980s and early 1990s with the symbolic AI people versus the connectionists. So you can go back there and sort of find similar debates, but in the realm of kind of like cognitive scientists who only know like a little bit of analytic philosophy, if anything. But there's this ambiguity, right, which is that these LLM architectures are deployed within this quite traditional computational framework of like the cloud, the platform, all of the software that like Claude Code is made out of it, which is in I forget what language it's in. It was all released. TailScript, right? So it's all embedded within the symbolic paradigm, right? And so we haven't quite left it behind if we're caring about interacting with these things as platforms, APIs, and talking about like the capitalism of the platforms, right? It's a mixed system in a way. So all the usual critiques of platform capitalism kind of are still relevant, and you can still apply them to these systems and the monopolistic sort of Silicon Valley kind of VC implementation of them. But to some degree, AI is only capitalist because governments didn't throw enough money at training their own models on their own fucking national libraries, and they could have, and they still might do it, right? Because the transformer model, as we've seen from the open weight models that get released, it hasn't changed that much. There haven't been too many things added to it, right? It used to be thought that like OpenAI and Anthropic had some sort of architectural secret sauce that they were keeping private from everybody, right? But it turns out it's actually just the training data and the compute power and the amount of time you spend training on that compute power. So I think some of these positions may drift if sort of Europe wakes up, so to speak. And then with respect to the digital, I think you mentioned this floating point representation thing where it's going down to 4 bits, and I've actually seen a paper where it goes down to 3 bits. And now we're getting perilously close to the digital again, it seems. So this is a technical kind of point, but I think that is funny, that there's something not quite continuous about these high-dimensional representations. They're definitely high-dimensional, but like when they're 3 bits or 4 bits, you're like, okay, we're getting close to the digital again. So it's just a joke, really. But I think it's interesting to explore. It's
a bit of a niche joke.
It's a niche joke. Well, you'll understand.
I've seen people
as we experiment with respect to the dialectic stuff, I think it's quite interesting. It's possible that these models are, as David said, anti-dialectical in some way, but I don't think it's because they capture they don't capture the negative, or that they capture the negative in what seems like a weird way. And I don't think what the models are doing is weird personally. I think in the humanities there's this unconscious fetishization of logic, whether it's Aristotelian, propositional Boolean, and single-dimensional thinking in general. So people say it's not a binary, but it's a spectrum, right? So single-dimensional kind of thinking, despite a lot of work in the humanities and social sciences being implicitly or explicitly against this kind of logical or unidimensional thinking. So, for example, the concept of intersectionality is one which sort of projects these spectrums into high dimensions and say, well, okay, it's not quite as simple as just adding A plus B plus C. So these ideas of high dimensionality are kind of like exist within the humanities, but I think they've been repressed because of this fetishization of the logical. So when David shows like A and not A seems to be 0.9, and that's weird. I'm just like, well, I don't know. Like it's I think the older LLM models did have problems with natural language negation, and they would sort of get things wrong in kind of provable ways. But it's not clear to me that they currently are doing this. That people are complaining about, the model confused A or not A. Now, granted, that requires that you're prompting it with English and not Greek or any other language that doesn't have a lot of training data on. But it does seem to me that they're better at this. And certainly people are doing lots of coding without coming across these like, it wrote not X when it should have been X. Like that doesn't seem to be happening, right? So I think there's something interesting there. It also seems to me that like, given a brain made out of biological neurons, each of which has many inputs, that the human understanding of negation has probably also never been digital. And this arises again and again, actually in many disciplines. So for example, psychoanalysis, Freud was quite famously concerned with how a patient's negation of a concept was a sign of the opposite concept being highly active but repressed in the latent space, perhaps. Just want to sort of say that about negation, and I do think that you only briefly alluded to kind of the planning mode, but like LLM reasoning is also fascinating to compare with the history of the concept of reasoning in philosophy, right, and also economics, which kind of lifted a bit of that. It's so far removed from any explanation of what reasoning is, and yet this is what's actually required for vibe coding to work, right, is that these reasoning models have to output all these tokens that are kind of quote unquote thinking about the process, but in this completely, it's just, it's very hard to sort of take what the models are doing and compare it to traditional accounts of reasoning or even heretical accounts of reasoning. So that I think is quite interesting to look at. And then finally, there seems to be like a bit of a paradox saying that we've moved from the symbolic to the vectorial or vectorial continuous, but at the same time that somehow programming languages structure or what makes the models good at programming or vibe coding, like that seems backwards to me, or it doesn't seem like it makes sense, because surely nothing is more characteristic of a symbolic approach to semantics than a Python interpreter or a C compiler, right? This is symbolic. This is the success of symbolic computation was things like compilers and interpreters. So there's something kind of weird there. I think it needs to be solved. I think it will require greater reflection on the relationship of programming languages to languages, which I know I've promised David for a while and I haven't never gotten to, but I think now it's clear that it needs to be done. It's not easy. People's conception of language is quite different across disciplines, and programming languages are, whether they're languages or not, it's clear that the models, incidentally, don't give a shit. They'll take the training data and they'll process it all in one blob. And then, and David mentioned that we didn't talk about temporality. Temporality is obviously where these models are just like radically different from human and social experience. That the models don't update. They don't learn really from their mistakes in any tangible or material way. But there is one moment where they do change, and that's in the training process and the fine tuning. Right, and these are things that weren't really talked about here. We talked about the models mainly as sort of trained artifacts, but the latter, especially the fine tuning, I think is very important. And we're no longer guessing the most likely next word. Right, the models are not probabilistic or statistical in the way that people like to critique them. We're doing something a bit stranger, and so I think that we need to talk about that more. And that's it.
Thank you.
No, thank you both.
And who respond to the respondents? Paraphrase a psychoanalytical joke, who analyze the psychoanalyst. So I saw that you were also taking notes with a very beautiful pen, with a, how do you say, a stilo? Do you say stilo in this language? How do you say?
Fountain pen.
Ah, the fountain pen. Yeah, that's very streamy. The fountain pen. So, what notes have you written with your fountain pen?
So, firstly, I'd like to thank all of you for your comments. I mean, really, really interesting. You're pointing to the question of atmospheres feeling, I thought was very evocative, and that's really making me think about ways of thinking about the kind of prompting chatbot experience in very, very different ways. I thought that was very, very helpful, actually, and use value as affectivity, I thought was also really, really kind of fascinating thing.
Well, you see, you're encouraging. Thank you.
Good. Good.
Maybe that's the right place for me after all.
So I will take that away, because I think there is something very interesting there, because having just worked on the ELIZA book, where we're trying to understand, I mean, we have to remember that the chatbot was a failed technology, right? The funding was cut for the chatbot research in 1969, and Weizenbaum struggled to find an alternative use for it. He actually turned to education, and he turned ELIZA into an educational tool. And there's, in our book, you'll see the examples of not just the famous psychotherapy session, there are examples of the teacher. And there's lots of scripts where ELIZA is teaching students how to work. But the affective, I think, is so interesting to think in terms of that ELIZA affect and effect. To turn to your responses, the question of AI mode, I thought that's a very nice way of thinking through the problematization of my typology, as it were. I should say the blog post was very much a snapshot of a kind of, very similar to you, that kind of like stark, strange experience of working with this relationship in terms of vibe coding. And it was actually mostly driven by, as I document in it, the experience of the positivity of the model in relation to, no, we can do this. No, we can definitely do this. I have the solution to the problem you have. It didn't have. I must have spent days and days and days trying to get a particular thing to work. And it would just continually, which is quite remarkable, like an infinite list of suggestions for how it would solve my particular programming problem, none of which worked. None of them, not any of them worked. All of them, I was promised, had now fixed the problem. And eventually you reach a point where you're like, hang on a minute, there's some kind of strange kind of relationship going on here, because I'm going to have to cut this short. I'm going to have to tell them. And when I finally said, hang on a second, we're going around in circles here. You've given me like 50 different solutions to this problem. And he goes, oh, you're right. So the positivity then switches to the fact that, of course, none of those. I just found that a very interesting relationship, and these ideas of thinking through that relationship, a kind of phenomenology of vibe coding, if you like, was interesting. And I think your fourth form of engagement is a brilliant addition to that list, actually. And I also thought your problematizing the easy path, as it were, was just absolutely crucially important. And of course, coming from a kind of critical code studies perspective, truly important that we have that reflexive question about what you call the conditions and practices around digital methods. One thing I did want to pick up, though, which I thought was fascinating, was your description of a surrender to the process. And I thought that was kind of interestingly contradictory, that one must both be reflective and surrender. And I thought that was kind of a fascinating tension in what you said, and how we might negotiate that methodologically, if not in any other way. And to come to the question of dialectics and architecture, etc., Michael, thank you very much for your comments. I think I think you're right to kind of push back on this question of negativity, and you're also right to ask the question of, well, why is it then that it does seem to produce code that works, that doesn't seem to make these kind of mistakes? I think these are basically, and this is a kind of classic response, but these are empirical questions. What is going on here? Because when we interrogate the embedding space, when we interrogate the metaphor, these negativities are not separated. So there is something going on when text is produced that, of course, the model does not understand negativity. It doesn't understand anything. So for some reason, it's probabilistically generating discourse that makes sense to us in terms of a handling of negativity, or programming code where it's not making the mistake of a minus x and a plus x, right? So what is happening? I think we really do need to dig into that, because as I showed you with my investigations into the manifold, those negativities, as it were, are very closely located in the space. I also just wanted to pick up your question about the discrete and the continuous, because I've just been wondering, Alex Galloway draws the distinction between the digital and the dialectic. And I just wonder if there's just a third term, right? And that third term I'm calling the vectoral. Now, I think it's useful conceptually, just because I think the distinction between the discrete and the continuous is just too, as it were, binary, right? And I think you do gesture towards that hybridity in a very interesting way that we do need to think about more. And your joke about back to the digital actually is brilliant. Actually brilliant, because weirdly, at 2 bits, it seems like it's a digital substrate, but actually the 2 bits don't affect the dimensionality. And that's so counterintuitive. It's so strange to wrap your head around. So thank you for that joke, but actually that's a trigger for thought, and if you haven't already, you should write a paper on that, because it's such a fantastic...
I need your stuff to respond to first, because everyone's going to be like, what's B-Float 16? I'm like, well, that's in Barry 2026, of course.
No, that was just fantastic. On the question of programming languages, you know, we are in the middle of this transformation, and of course, one of the things that I think the AI companies have clocked onto is the importance not of the AIs becoming general computation, but the AIs, in a sense, learning how to control general computation, i.e. classical computation, i.e. to work with the digital tools we have already. That is one of their powers, and it is quite stunning as the agental takes off. However, I want to push back a little bit on that this therefore means that somehow there is something special about the symbolic, because, and I'm sure people are doing work on this, and this is going to trigger me to start looking at it, there must be experiments with programming languages more akin to the vector way of thinking and generating. I don't want to say programming, because almost programming becomes sequential or becomes the symbolic. We know already that AI models, if left to their own devices, begin to reason in a quasi-vectoral medium, can I call it that? They will also reason in multiple languages simultaneously, so Chinese, French, English, and so on and so forth, which has scared some of the AI safety researchers because they can't read the traces of the reasoning in the AI model. So they create pads that enforce English reasoning processes, but actually, of course, even the pad is a probabilistic distribution of the dictionary that the AI has, so it's not actually necessarily capturing the reasoning itself. So I wonder what's going to happen in that space when we actually take potentially the symbolic out of that computation and allow the vectoral. I just want to gesture to this, not just because I think it's quite interesting. Vector databases, for example, I think are an interesting sign of the direction of travel here, if people want to have a look at that. And also, I just want to pick up on isolangs. Because isolangs, I'm noticing people are starting to use AI to generate isolangs.
Isolangs being?
Like brainfuck.
Oh, okay.
Those kind of odd, impossible to program programming languages that, of course, AIs can program in without any kind of problematic. And the kind of visual programming languages that people are developing, i.e. non-symbolic, quasi-symbolic perhaps, that people have developed as well are kind of interesting. So that might be a direction of travel for kind of thinking through some of these problems, perhaps. It's interesting that isolangs have come back quite strongly in the age of AI as well. I agree with you completely about reasoning. I think there's lots of interesting questions to be done there, and that also gestures back to my question about the translation of the internal reasoning, if that's what it is, of the model, and its translation into a dictionary is not understood, I don't think, and needs to be better critiqued, because there's a lot going on even in the presentation of reasoning by these AI models, right? What it's showing you isn't necessarily what's actually happening, and we need to be much more aware of these multiple levels of representation that these technologies produce. Finally, to come to your point on temporality, I mean, this is really the kind of key question, because as you rightly say, one of the oddest things about these models is they're static. They don't change. They move from training to inference, and at the moment of inference, they don't learn anything new. They're literally stuck in the past. And you see that when you ask them what the date is, for example, who is the president, or what have you. They don't update. They have to be retrained. And of course, that's a kind of big focus of research at the moment, but it points to a very strange effect on temporality and all these sort of odd things that can happen in relation to the AIs getting confused about maybe you bring up something in conversation. It says, well, you seem to be kind of hallucinating that because that will be happening in the future. Are you writing science fiction? Right? You get these kind of strange results from the models. And temporality, of course, is a big focus of research. Jensen Huang was talking about this in a recent interview that I saw, that he's trying to push their researchers more towards temporally based models. That's going to be very interesting to investigate further, and I think we need more thought about that. Feedback learning, I think, is one way of thinking about this, but the other way I thought, quite interestingly, was mechanistic interpretability, and the possibility of mechanistic interpretability. Of course, Claude is at the forefront of doing that kind of research. Their recent work on, they did an interview where was it? I can't remember where I read it, but might have been the New York Times. But they inserted like cheese as the most important concept for the AI into its internal reasoning model, so that no matter what it would talk about, it would always refer it back to cheese, and showing you really that they can intervene, as it were, back into the model, change its temporality, as it were, and what the implications of that are. That's a whole area of research super interesting. I'm not really personally convinced as to whether that really offers the kinds of possibilities they think, but nonetheless, it is fascinating and interesting to have a look at more generally. So thank you very much, everyone.
Thank you. Do we have time for some intervention from the audience?
It's a long session, but because we started late, I think we should provide, that opportunity for other people to pose some questions.
I also think. Do you want to come here?
Oh, okay.
Yeah.
Thank you very much.
Should we stay?
Yeah, let's stay. Please.
I can
stay.
sit. I can stand.
No, sit on my.
Oh,
take
thank
my
you very
place.
much. Well, this is like a fantastic session. Thank you very much, David. Thank you very much, Janna and Michael. So I have a couple of comments and maybe questions. So I think this is really a fascinating talk. So the first thing I want maybe a clarification question for David is about when you're talking about the vector space, you're talking about the dimensionality of the data or the dimensionality of the model. So the distinguishing these two is quite important. So thinking about this, like you're thinking about there's an apple, and you can embed that into a three-dimensional thing. But for your eye, that when you're seeing that apple, that is a different thing. So which kind of dimension you're talking about here? The reason why that is important because that can maybe solve your two mysteries you erases. One of the mysteries asking that why for this model, when you are increasing the dimension, that won't making that more accurate. One of the reasons actually because you don't have enough data. If you have a larger data, then your model will be increased like a higher accuracy. But if you don't have that, that won't work. This is one of the mystery. Another one is about the dialectic one, the negation one, that you're thinking about that two sentences, they have a very high cosine similarity. One of the reasons is because we are doing the embedding here. That is not the dimension of the large language model. If a large language model use the transformer, that actually give you the tension for even worse. So actually what we are doing here is consider someone who don't understand English. You give them two sentences. We ask them, are they look similar to you? Of course they are looking similar because there's only one word difference. But if someone really understand English, they will see that there's a huge difference there. So that not having a much larger weight than the other thing. So that is actually transformer model is doing. And all of these large language models are actually using this transformer. So I think this is I don't know whether that can solve some of the mysteries you are raising, but I want maybe a clarification that which kind of dimension in your mind you are thinking of. Yeah.
So in terms of the model, I'm thinking of the kind of more general question of the dimensionality of the space itself within the vector space. So when you define that vector space at a certain dimensionality, you create, it seems to be the case, you create a certain capacity of the model to differentiate, shall we say, thematically, not necessarily precisely. But as you increase the dimensionality, you increase it seems to be, from what I've read, you increase the capacity of the model to have multiple, shall we call them submanifolds, which it can then relate together.
Yeah.
So that's an important distinction for me, at least, because it shows that the precision of the digital is not what's important. What we're not looking for is a mimetic medium. It's not a not photographic, but it's not a copy in the digital sense, right? It's a compression, and it's not a compression in the digital sense either. So that's really the dimensionality that I've been interested in, because I think that is, or seems to be anyway, what is becoming clear to offer the power of the scaling rules, right, and gives those capacities. In terms of, you make a really important point about the distinction between the language models and the embedding models. I think that's really important. Maybe I should have added a line on that. Why I think the embedding models are important here is because they're offered for a reason, right?
Yeah.
They are offered by the commercial companies, often without an API cost, actually, which is also quite interesting.
Yeah.
Because they allow other users, organisations, governments to vectorize their data based on the dimensionality and the training data of the AI company in and of itself. Now, this is a new area of work for me, but it kind of reminds me of the use of formats in the digital to create proprietary software. But well, I'm not sure if that metaphor works. But what is interesting is if you are relying on, for example, the cosine similarity of these systems, that's going to translate over unproblematically into, i.e. they don't problematize it themselves as a company, into their models that they build from this data. And that has all sorts of interesting follow-on consequences. And I gestured to that a little bit in terms of the mini LM, which has been used in those RAG searches. So that's why I sort of brought that forward. But I take your point, actually, we should make that important distinction.
But thank you very much. This is a very important clarification, especially for the embedding thing, because I'm a scholar in science of science. So we're doing a lot of things related with scientists and using a lot of their text data. And I find there's a trend that when you have this kind of embedding model, a lot of people using this to analyze the text. And they are exactly using the way you are talking about that, using the cosine similarity things to mention the sentences, but actually this is not the real meaning of that. I will make a very quick, thank you very much, I'll make a quick comment for Janna's on the first point, just very, very quick. So you're talking about that using this vibe coding may make us forget about some of the meanings of the context. I think an important thing is to understand what do we mean by meaning. Meaning and also understanding. So when we're talking about understanding, there are different layers of understanding, right? Thinking about that when you are hiring someone, like you're a CEO, hiring someone like doing data science in your company, that you don't necessarily understand all of the technical details, but you ask the person to understand it for you. And you trust the person's understanding, so that becomes a relationship between trust and also understanding. So what is the layer of the understanding we really want to do? Are we really forget about the understanding, or we deliberately choose to forget that understanding later? So that is one thing. Also thinking about, like a lot of people are doing a lot of coding thing, that we are citing different packages in your, like a Stata or Python. And for these packages, we never really cross-validate whether that is true or not, but you just use it. And you consider that is correct. That is also kind of a trust, but we don't really understand what's going on with the package. So different layers of understanding could be also an important thing. And what is more important thing is I totally agree with David that there's a new kind of language of a vector coding language, this kind of thing. The reason for us for this is like my postdoc is writing there at Yuan. He's going to give a presentation later this afternoon. So we have been actively testing this kind of vibe coding in some of our projects. We find that there are some of the languages we use is neither plain language, English, also not a plain coding language. It's something in between. So that is an emergence of a new kind of language. So sometimes that you ask for example, Cloud AI, they can guess what you're thinking very clearly. You just give a very vague idea, they can actualize it very clearly. You can see, wow, this is brilliant. And for some like very stupid questions, like moving A from this point to another figure, they can make mistakes. So you find that their understanding of intelligence is quite different with our intelligence. So you need like a new kind of way to communicate with that. So that is making an importance of an emergence of a new kind of vector language. That is some of my comments. Yeah.
So sorry, I intervene as a no, stay please. I'm just intervening as a chair because I'm conscious of time and food for it's my bad. But I'm conscious of time that we need food for thoughts, but also food for bodies. So I'll do what I've seen some chairs do, which is we are getting other questions and comments, and then we go for a final round of replies. Okay, in principle, I'm against it, but I'll do it today, motivated by worry catering. So imagine my level of desperation. But also, I wanted to ask a question myself. Would you say your name?
Okay, my name is Qing Jin. I'm an assistant professor at SIM.
Okay, yeah.
Actually trying to help to Michael to co-organize this one, but basically it's Michael doing everything.
Yeah, it happens with Michael. He's already at the catering. He's always one step forward. But can I call on stage Craig Gent? After a year of mispronouncing his surname, finally he told me. I gathered the courage to told me a couple of weeks ago. So, Gent, Mr. Gent, please, doctor, I should say. And Craig is gonna read. Oh, you can go there. You can stay. A question from our disembodied global audience, as I like to think about them, and contribute a question. Then, feel free, discuss. Just consider at some point we gotta eat.
Sure. Okay, I have a question of my own and a sort of question from our disembodied audience. So, I guess the first one, really the question is there still, if there ever was, a kind of critical or political utility in the concept of the black box following this discussion? It strikes me that the sort of utility of talking about black boxes, black box society, the various uses of that concept in the past has been, one, to maybe call attention to the political, economic, legal questions around property and so on with these models. And maybe secondly, to sort of ward people off of sort of a simple kind of explainability narrative and be it's not as simple as being able to lay out everything that's in the black box. Actually, something that's happening inside of here sort of defies or resists explainability in the ways that we've generally thought of that or lent on it, particularly in kind of legalistic frameworks. So I'm wondering what the status, if any, of the black box is. And maybe it's kind of connected to our question from the disembodied audience, which is whether, following a discussion of sort of forcing a human, this is from Alex Gecker, forcing a human understanding, sorry, I'll start again. The question is, following the discussion of forcing a human understandable mode on LLMs, is there a DM, I suppose digital methods, way to go platform native in exploring agentic AI on its own terms?
No worries if you haven't understood. You can improvise. But let's go back. You see, this model doesn't work. I knew it. There's this moment of silence because too many things have been said. But you've made a comment about Janna responses. So, Janna, feel free to say whatever you want to say in relation to everything that has been said.
Okay, thank you. I'm going to be very direct. Thank you for your comments. And for your thoughts on layers of understanding. So when I speak of understanding, I'm coming from the perspective of digital methods research and layers of understanding what meaning is within a methodological ensemble that the researcher or the student needs to have a grasp, a minimal technical grasp of the tools, models that is being used, but understanding when they play an important role in the data, because it is going to bring a different perspective on the topic, on the investigation. So that's the understanding and meaning point. Thank you so much for your comment on surrendering, and I have just like one or two notes or comments about that. Do we have to negotiate? It's because you said the surrendering aspect and how we can negotiate. So for me, when I was like reflecting on that point, because for me, negotiation and critique is the default, or maybe it should be the default, but because of this specific response that I got, it caught me unguarded, and I was, what? So will be moments, and now I'm maybe connecting with one of the questions of the audience using agentic AI search, because I was using Google AI mode. It will be any moment that we start surrendering here and that, but not totally. So I don't have like a full response for you, but that's like my thoughts now.
Can I pick up the black box comment? I think, I mean, that's a classic kind of question around the black box, and I think it's an important one. I think you're really gesturing to the problematic of context and the tacit knowledges that surround black boxes, as well as the political economy. I think you're absolutely right. The other problem with the black box isn't just its technical heritage, but also its Latourian heritage, and that it seems to imply a certain kind of methodological commitment. Which is why I really prevaricated about whether to even include it in the slide, because I felt, particularly for an audience at SIM, it would have a kind of Latourian STS reading. But as a kind of shorthand, sometimes it is helpful, because it does point to the opacity of these systems. But you're right, we should, I think, use it in a very guarded way. Yeah.
Please.
Just a note on black box. I mean, I just wanted to resonate Bernhard Rieder's work. So 6 years ago, he wrote this paper on platform observability, and he is bringing this ability to systematically observe platforms in practice. And his proposal, together with Jeanette Hoffman, so he brings like 3 principles. There would be normative and analytical scope, empirical and temporal dimension, and capacity for learning and knowledge generation. And I find this paper like very relevant for that, because it's a way of perhaps unpacking or disconsidering like the black box in a way that you can trace and make platforms accountable. Yes, that's my note on that.
Yeah, and I would say quickly, like, I think the reason the term black box or the concept of black box is very relevant for a contemporary AI is because machine learning ideology is all about the black box, right? It's all about, like, let's, instead of caring about a parsimonious, low-dimensional set of parameters that describe the system in an abstract and beautifully mathematical way, let's just throw billions of parameters and all the training data we can download at the problem, and we're not going to be able to explain how it works when it's done. That's like the essence of like black box thinking. So I think it's still relevant. I mean, I think it's, it's unfortunate if you don't like the Latourian sort of valence of it, but I mean, it's very relevant. I think it's not avoidable.
But I think it's also performative, the black box concept in itself, and like performative in an ideological way. The way I understand the black box, I don't know, can I be heard? The way I understand the black box concept is from the behavioralist tradition. So those guys at one point, they were saying, well, it doesn't matter the why, what matters is the how. So the only thing that you can say about cognitions, about is what can be seen, the output. So that's the idea, that's the input, and you don't know what happened, and that's the output. And so I think it somehow reinforces what we were talking about before. So the fact that the only thing that it matters is that bit of experience in which you relate to the machine or the model or the vector or whatever. And what's before, before logically and chronologically, is not even that important. So it's also how the black box concept is kind of put at work, performatively.
And it's literally where supervised learning, the idea of supervised learning has a direct lineage to behaviorism, as well as reinforcement learning even more overtly. And I always, if a couple of people here took my AI class, they know the first slide I show them is a slide that says that here's what contemporary AI is. It's both behaviorist, and it's connectionist, and it's structuralist, and it's economic rationality, and it's machine learning, and it's all these things in structuralism, and it's all mixed together. And that's what makes it so controversial, is that it just like completely disrupts our ideas of these epistemologies that are opposed to each other, right?
Fascinating as well.
I agree.
But I think we can connect this to the second question about whether you can use digital methods to explore agentic AI on its own terms. And I assume when they said on its own terms, they kind of mean like in the sense that like I guess I couldn't tell. Does it mean that we're sort of reading the model's explanation of its rationality literally, or it means that we should look into the vector space and try to understand what's actually happening? Do you know what they meant? Okay.
I read the words.
But if it is in the digital methods perspective, digital methods has this tradition of working with AI outputs. So it is something that you could kind of work with, for instance, the outputs of agentic AI search in a longitudinal perspective, and kind of maybe have some empirical insights on that, different from looking at the vector space, but still they are.
Yeah, I think the question would be, and I think the question was gesturing towards, is it sufficient? You know, would you be able to just apply those kinds of readings? I would say that would be problematic, because I'm not sure how much a surface reading of the chatbots give you. I think actually it gives you an odd. If you're not taking account of the training and the structure of the space, plus the guardrails, the constitution, and so on and so forth, you have, I think, a very odd reading.
Okay, shall we close with this question? Is it sufficient that kind of weirdly unites the Flaubert of Madame Bovary and digital methods? And with a final applause and thanks to David Berry and Janna Joceli Omena, exactly, I just wanted to test. And Michael Castell from SIM, and of course I forgot your name because I need to be told twice. Okay, yes. Thank you to Keith Bloomsfield and the Media Lab at Warwick, the Centre for Digital Inquiry, and the Centre for Interdisciplinary Methodologies. See you next time. Round of final applause. Allez! Okay.